Hey everyone, I am Aminos from China. Some of you might know this. Ever since the America and China started their trade war, both countries have banned a bunch of each other products. Like Donald Trump temporarily paused TikTok America business in early 2025 and blocked Xiaomi cars from selling in the West. In return, China banned Fortnite. Yeah, if you play on Asian servers, you will rarely run into Chinese players, even though they are the
50,000 people
largest
used to
group
live here.
in East Asia.
Now it's a ghost town.
So maybe Unity, being a fully America based company, is worried about getting banned in China too. That could explain their another controversial decision, splitting Unity into two, Unity Global and Unity China, also known as the Tuanjie engine. For more on Tuanjie, check out Game from Scratch video. But worse than splitting the community, Unity China is forcing all local developers to switch to Tuanjie by mid 2025, and even blocking access to Unity 6. I am not a fan of Tuanjie, and I am not optimistic about Unity's future in China. So I decided to switch to another engine that feels a lot like Unity, UEFN. UEFN is a pretty new engine, been out less than 3 years, so most of you might not be familiar with it. Quick intro. UEFN stands for Unreal Editor Fortnite. It is an upgrade from Fortnite Creative, letting you build games inside Fortnite using some UE5 features and Fortnite devices. You might be thinking, UE5 tools and Fortnite devices. That sounds nothing like Unity. But wait, check this out.
So this structure that we've built, this tree or graph, that is what we're calling a scene graph here. We have components, we have entities, and we have prefabs. And if I make changes to the prefab in the future, all my instances can get those changes.
It's our unified structure connecting all the objects in our scene. Our code can walk through the graph and perform operations on objects. So if you're familiar with developing in Unreal Engine today, that is currently the actor and actor component system. But this is a new system, so we're eventually going to bring this over to Unreal Engine. But last week we launched it in UEFN first.
So, the scene graph system completely ditches the old actor and blueprint model, goes full entity and component. When you use scene graph, UEFN starts feeling less like UE5 and more like a special version of Unity. I am not exaggerating. I actually built the same game in both engines. But why would I do that twice? To be clear, this is not my original game. It is Code Monkey's. When I switched to UEFN, everything was new to me, just like when I first learned Unity. Back then, CodeMonkey released what I still think is the best beginner Unity tutorial out there. I followed his 10-hour video step by step, hands-on, and that is how I got comfortable with Unity. Now, I am in the same boat, learning a brand new engine, and the fastest way I knew to get up to speed is rebuild that same project in UEFN. So yeah, the game and all its art assets belong to CodeMonkey, full credit to him. Based on building this game in both engines, Unity and UEFN differ in a lot of ways. Here are the big ones I had noticed. Let us start broad. Number 1. Editor Interface. Both Unity and UEFN are mature engines with dedicated useful editors for different modules: material, particle, animation, prefab, etc. When you open them, they pop up in floating windows by default. In Unity, when you maximize a window, it becomes a separate layer floating over your layout, and it is not easy to switch between them. Most devs just drag it into the main layout, turning it into a tab. Then you work inside that tab. In UEFN, when you maximize a window, you can drag it into the system level tab bar. That means even with a window maximized, you can still switch editors easily using the top tab bar. Big usability win. Number 2. Scripting languages and code editors. Unity uses C#. It has been around a while, so tons of code editors support it: Visual Studio, VS Code, Writer, etc. You can pick your favorite, and each has a ton of plugins. Take Writer, which I use. Open a script like Delivery Counter, and at the top, where you import packages. The editor analyzes which ones you actually use. Unused ones get grayed out. Save to delete. If you're missing ones, it will remind you and auto-import with a shortcut. Syntax highlighting is solid too. I use the one dark theme, C# keywords in purple, class names yellow, fields red, methods blue, parameters orange, locals white, and control plus click a property. It shows you every place it is used. UEFN uses Verse, and right now editor support is not great, maybe because it is so new. For now, UEFN only officially supports VS Code for coding, and third-party Verse plugins for VS Code. None of them are really good. Even Epic's own plugin does not come close to what Rider offers for C#. Like in the worst version of Delivery Counter, forget about auto-import or dependency analysis. They don't exist at all. Even syntax highlighting is completely broken. Why are class fields blue when declared, but red when used? Why is if red, while else is purple and italicized? Even Control plus clicking a property gives no reference navigation, and for some classes, you can only jump to their definition once before the feature stops working entirely. There is so much more to say about C# versus Verse, enough for a whole other video. Bottom line, Verse as a new language is more modern and cleaner. It supports a lot of features from today's programming languages at the syntax level. On paper, I actually prefer Verse, but the coding experience is so rough that overall it is nowhere near as good as C#. Number 3. Update logic and stability. Unity like UE5. As long as you create a project with a specific version, the project can always be opened with that version, and the editor will not force an update. However, UEFN updates automatically with Fortnite, and various stability bugs may appear after each update. I ran into one recently. Check my last video for details. Fortunately, the UEFN team fixes issues quickly, and my problem was resolved within a day. Number 4. Singleton usage. In CodeMonkey's tutorials, the player and all the manager classes are set up as singletons. Unity makes it really easy to create singletons, but UEFN's Verse language doesn't have a static keyword. Right now, you can only use a session-level weak map to implement similar functionality, or you can dynamically create components after the game starts up and add them to a sim entity.
Singletons are a little bit weird when it comes to Verse. Verse globals are meant to be truly global. So someday in the future, if you create a global variable in like a shared Verse module, you would be sharing that one global across all uses of that module. So if you're sharing it between 6 games, all the games are writing to the actual same instance of that variable. So singletons become a problem there because if you're trying to create a global, you might not have expected it to be one for all your games. You think it's one per game. The way that I would do it within SceneGraph is that I would create a component and I would dynamically add that to the simulation entity so that you can find it from any of your other entities. So you basically just kind of mock out the idea of a singleton, but by hanging it off of an entity that you can always find within your game.
Number 5. Observer pattern. Since we're talking about singletons, we should also mention the observer pattern that is often used with them. In CodeMonkey's project, the animations, sounds, and UI responses, after the player interacts with the counter, are all implemented using the observer pattern. In Unity, developers can use the C# actions and events, as well as Unity's built-in Unity action, so creating, subscribing to, and triggering events is really convenient. In UEFN, Verse also has an event keyword, and the logic for creating and triggering events is similar to Unity, but these events don't support subscription, so developers have to keep waiting for events to trigger inside a loop. Thankfully, SG provides a completely different event system called Scene Events, which is even easier to work with than Unity Action. But unfortunately, Scene Events are still experimental. If Epic can complete their development on schedule, Scene Events will become available next month. Number 6. 2D Model and World UI. In Unity, you just set the image type to sprite, and drag it directly from the content browser into the scene to display 2D models. Showing UI in world space is even easier. You only need to set the canvas to world mode. UEFN cannot do either of these things. It can only achieve a similar effect indirectly by using plane meshes, just like how you display 3D models. Number 7. Overlap UI. As for the actual overlay UI shown on the screen, Unity's UI allows you to add custom scripts directly to any UI element. By contrast, UEFN's user widget only supports statically binding view models in resources through MVVM. For dynamic binding such as dynamically generating waiting menu lists, UEFN doesn't currently support this because you can't access UMG elements through Verse. You have to use Verse UI instead, create everything from scratch in code, and set the data manually. However, UEFN's Q3 roadmap includes scene graph support for UI, which might work like Unity's world mode and overlay mode canvas. Number 8. 3D related features. For Unity, displaying a static mesh with a collider in the scene requires 3 separate components: mesh filter, mesh renderer, and mesh collider. By contrast, UEFN only needs a single mesh component, and both collision and material functionality are implemented through the fields of this mesh component. As for 3D animation, UEFN is equipped with Unreal Engine sequence system for animations related to actor meshes. However, in Scene Graph, only the keyframed movement component can currently handle transform-related animations, and support for skeletal mesh animations will not be available until the second quarter. Number 9. Organizing and referencing data. In CodeMonkey's project, all kitchen object-related resources, including prefabs, textures, and names, are stored in scriptable object, and these scriptable objects can be dragged and assigned to scripts in the editor. While in UEFN, I know that has data assets similar to scriptable objects, but developers cannot create custom types of data assets. As a result, the only available option in UEFN is asset reflection, where all data has to be stored individually in assets digest and cannot be organized as collections like Unity's scriptable objects allow. This is quite inconvenient, and I really hope Epic will develop similar functionality for UEFN. Number 10. Networking. In another of CodeMonkey's multiplayer projects.
In this lecture, we're going to handle player movement. And as we're doing that, we're also going to talk about something extremely important, whether to make your multiplayer game server authoritative or client authoritative. Both methods are valid, I'm going to showcase both of them, and then it's up to you to decide which one best fits your game.
He spent a lot of time explaining and implementing network variables, which are variables that can be synchronized between players, and this leads to the biggest difference between the two engines, network variables and the authority model. Unity does not have network variables or an authority model by default, but developers can manually import the official network toolkit as needed, which provides a single user authority network model. While in UEFN, it uses server authoritative networking by default. Every variable is a network variable and they work just like regular variables with no extra setup. I didn't even realize this until I saw it discussed on Discord. It massively simplifies multiplayer development. But as a result, UEFN does not have a local tick. It only has server tick, which is 30 TPS. I think a lot of you know this feeling, whether you are switched code editors or operating systems, when you are fluent in one tool, then suddenly get stuck on basic stuff in a new one. It is incredibly frustrating. Why can't it be dragged? Tasks that used to take a minute now take a whole day, because you go from knowing exactly where everything is to knowing nothing. It really shakes your confidence. But if you push through, keep going, despite the struggle, that frustration fades over time. So do not let the newness break your confidence. Look at me, I am using UEFN in China, where there is basically no community and 0 official docs in Chinese. But I still managed to recreate CodeMonkey's 10-hour tutorial project. Finally, let me talk about this channel's future plans. Honestly, I am currently immersed in the joy of successfully replicating Kitchen Chaos with UEFN. I have not decided what my next project will be or how to approach it. I have also wondered if going all in on UEFN development at this point is too early, especially in an environment like China where there are almost no Fortnite players or UEFN developers. That's why I started this YouTube channel and make videos with my poor English. I believe too few people in China understand UEFN. I hope experienced developers with UEFN experience can give me some career advice as a newcomer. Of course, if you have anything to say, feel free to leave a comment.